talk about what ground means. Now, the general symbol for a ground in a circuit diagram is something along those lines right there, where it sort of dead ends someplace. Now, if I have a sphere here with excess negative charges, those charges want to get away from each other. So the question is, where are they going to go? You can imagine an ideal where you have some location which can take as many electrons as you have to provide. And so that is really what we call ground. It's just some large area here that if it's connected, there's plenty of room for all the excess electrons to go. If I have something positively charged, then it'd be nice if it connected to something that can provide as many electrons as I need. And so I should actually connect it up there. And so as many electrons as needed will go up. So up here, as many electrons will go down. And this is ground. Now, it's obviously called ground because the Earth is a great place to provide electrons or take electrons, whichever happens to be needed. Now, it doesn't necessarily have to be the Earth itself. It can just be any large object that has plenty of space for taking extra electrons without too much bother, or for giving up electrons. So your body itself could be considered a ground in many cases. And so if we're dealing with the electroscope, we ground it by neutralizing it. When we touch it, we basically are either providing electrons or giving up electrons, whichever way it happens to need. So a ground in electricity is dealing with just a large reservoir of either negative or positive charges that can either supply or take electrons as needed. That's ground.